Good morning, everybody. Very, very good morning. Operating system notes. OS. 26 January. Hello, hello, hello. Good morning. आप सब लोगों को रिपब्लिक डे की बहुत बहुत बधाइयाँ. Very, very happy Republic Day. Shailaja, very, very welcome. Good morning. ये शॉर्ट नोट्स नहीं होगा, इसका है. Very good morning. कैसे हैं आप सब लोग? How are you all? You all well? Everything is good. Happy Republic Day to all of you. Happy Republic Day, ज्योति लक्ष्मी. ये दो नाम एक साथ क्यों, ज्योति और लक्ष्मी? एकदम बढ़िया. आप भी ठीक हो? हाँ, एकदम ठीक है. ऑल वेल, एवरीथिंग इज फाइन. गुड मॉर्निंग प्रशांत. वेरी गुड मॉर्निंग. हैप्पी रिपब्लिक डे. लड्डू मिला कि नहीं मिला? और हैप्पी रिपब्लिक डे टू यू टू. ललित, विशिंग यू द सेम. सर गए नहीं? अच्छा यार, जाना चाहिए था ना लड्डू खाने. सोसाइटी में रहने का ये फायदा है. आपकी क्लास लगा. ओहो, सुबह मैंने सेशन लिया. सेशन के बाद में हाफ एन आवर का ब्रेक था. मैंने ब्रेकफास्ट किया और चले गया मैं नीचे. अपनी सोसाइटी में सेलिब्रेशन हो रहा था तो लड्डू लेके आ गया. आपको भी बसंत पंचमी, सरस्वती पूजा की बहुत बहुत शुभकामनाएं. गेट क्लियर करके ही खाएंगे अब? ओहो, फिर तो मेरा भी हक बनता है. गेट क्लियर करने के बाद आप लोग सब मुझे भी बहुत सारी मिठाइयाँ भेजेंगे. आप बैंगलोर में हैं तो वहाँ कौन सी सोसाइटी? सोसाइटी तो बहुत सारी होती है. बैंगलोर में सोसाइटी नहीं होती क्या? सोसाइटी का यहाँ पे मतलब होता है अपार्टमेंट बिल्डिंग. एक गेटेड कम्युनिटी होती है तो गेट बाहर से क्लोज. हर कोई अंदर नहीं आ सकता अंटिल आई गिव द परमिशन. फिर यहीं पे सोसाइटी में सब लोग मिलके और सेलिब्रेट करते हैं सारे फेस्टिवल्स. मेरी सोसाइटी में तो क्रिकेट ग्राउंड भी है विद लाइट्स. यस, फ्लड लाइट्स के साथ में. नहीं, सी बैंगलोर इज वर्सेटाइल इन द कल्चर. यहाँ पे आपको सब लोग मिल जाते हैं जस्ट बिकॉज ऑफ द यू नो द जॉब्स. तो आपको सारे स्टेट के सारे कम्युनिटी के लोग आपको एक बड़ी सोसाइटी में रहने को मिल जाएंगे. एग्जैक्टली लाइक गोकुल धाम सोसाइटी, बस वैसा ही है. आप खेलते हैं क्रिकेट? ऑफ कोर्स खेलते हैं. क्रिकेट कौन नहीं खेलता भाई? आत्मा कांप रही है. डेट नजदीक आ रही है. देखिए उदित जी, ऐसा है, ये डर जो है ना, ये इंसान को सक्सेस से दूर ले जाता है. वेरी गुड मॉर्निंग परनीता. अगर आप डरेंगे तो आप सक्सेस के नजदीक नहीं जा पाएंगे. सेल्फ बिलीव सबसे इंपॉर्टेंट है. अगर आप कोई भी बड़ी चीज करना चाहते हैं, कोई भी, जैसे जैसे बाहर से लेकर कोशिश वही है कि आई कैन गिव यू सम एक्स्ट्रा यू नो practice. Sai Ganesh, just go to my profile. Under my profile, you will have COA and OS practice courses. Under my profile, on my profile, under the category GATE CSIT lectures, just check out practice courses of COA and OS. देखिए डर हर किसी को लगता है, मुझे भी लगता था एंड लगेगा, everybody will be definitely into that situation, but you will have to understand the situation that this is a gate paper. Sai, I have not taken anything, any course on CN. Reddy sir might have taken the course on CN, so check it out under his profile, computer network. Okay, so you guys will have to understand one thing. You guys are preparing for GATE exam, which is national level exam, and lakhs of members, thousands of members are trying to crack it in your branch itself. So it's definitely a very big exam, and if it is very big exam, 100% sure it is, or that's 100% guaranteed that pressure will be there. But who will win in that situation? The person who is able to hold the nerves will win the situation. It's like World Cup, of course, of any sort, any kind of game, any sport comes occasionally once in a year, but that gives an immense amount of pressure. The person who can handle the pressure, can perform under pressure, will come out as a champion player. You might have not even watched, even at least you might have heard about World Cup, football World Cup just now completed, right? Last month only. So what was the specialty of that? Just few players have come out as champion players just because they were able to hold their nerves in the pressure situation. It's not only one player. There are so many such players. So pressure handling is one of the key element of cracking any big exam. I'll tell you last year's example. One of my student, he was connected with me throughout the year. Throughout the year. Just day before GATE exam, he was into such kind of a panic mode that he ruined his paper. Now you decide, 1 year complete preparation you have given, more than that also. Do you want to ruin that 1 year preparation just because of one single thing that I got panic, sir? Why you got panic? Why? कोई तलवार लेके खड़ा रहेगा वहां पे, कोई बंदूक लेके खड़ा है वहां पे. Somebody is standing there in the GATE exam holding the gun. पेपर सॉल्व नहीं किया तो गोली से उड़ा दूंगा. It doesn't happen like that way, right? Nobody will kill you. Just talk to your parents once. Just because they are having maximum expectations from you, just tell them the real situation. Confront. I have prepared this much. I have worked on this much. Let's see how much I can score. Just because it's like I don't know how will I perform in those 3 hours. Confront. Before GATE exam, I told my father my preparation is well, but पता नहीं कि exam कैसे जाएगा. My father told me one thing, अरे it's okay, tension मत ले. Don't take tension. Everything will be fine. I didn't take tension. Everything gone fine. Same thing. Just confront with your parents. What is the situation? If any worse situation is there, then too they will support you. Good situation is there, then too they will support you. If they will support you, you will be normalized. Okay, ठीक है. You take pressure of what? Pressure of outside elements. If I will not get good rank, my neighbors will think about me what? My parents will think about me what? Vishvadeep sir will think about me what? अरे मैं कोई बुरा नहीं सोचूंगा. If you have prepared well, this preparation somehow will help you in any of the cases. Doesn't matter what. If you will score 45 also, you are as lovable, as good as for me as you if you will score 65 also. I don't discriminate between these two kind of students. रोस्ट तो दोनों को करना, चाहे आप 70 मार्क ला रहे हो तो भी, चाहे 30 ला रहे हो तो भी, गेट की एग्जाम नहीं लिखोगे तो भी रोस्ट तो होना ही होना है. वो आपका जन्म सिद्ध अधिकार है, उसके लिए आपको रेडी रहना पड़ेगा. चंदन, फील होता है कि भूल गए, बट ऐसा होता नहीं है। पेपर लिखते रहो सर। घर वालों से ज्यादा आजू बाजू के, अरे तो आजू बाजू के लोगों को इतना ज्यादा क्या है टेंशन लेना, जज करने दो उनको। उनका काम ही है जजमेंट देना, एनालिसिस करना। हम एल्गोरिदम की एनालिसिस पे कंसंट्रेट करते हैं, वो लोगों की एनालिसिस पे कंसंट्रेट करेंगे। निशार्थ, इफ यू हैव लेफ्ट इट, इट्स ओके, लीव इट। यू डोंट हैव टू वरी अबाउट इट। इफ यू लेफ्ट इट, लीव इट, डोंट वरी। ओके, why you guys are worried about near around people? If you will get better result also, they will talk negative only about you guys initially. मेरी रिजल्ट आई थी, मेरे मेरे रिलेटिव्स आधे से ज्यादा तो यही बोलते थे, अरे कुछ तो जुगाड़ किया, तुक्का लगाया, ये ऐसे कोई इसकी रैंक आती है क्या? People will talk negative. You don't have to take that particular pressure on your head. It's their work. Let them think. चार लोग क्या सोचेंगे, अरे वो जो सोचेंगे, हमको क्या सोचना, उनको सोचना है। अगर वो भी हम सोच लेंगे तो वो क्या सोचेंगे? Abdul, here word offset is not needed at all. The question was about only tag. There is no any word offset needed, just because memory is byte addressable, and you'll have to calculate only byte offset, not word offset. See, you just talk to your parents. Parents से बात करो. If they are fine with you guys, that's okay. Just because that is the only inner circle you should be worried about. Your parents should not be very dejected by your decisions or your results. That's the only thing you will have to do. That's it. When I have switched my job from IT to teaching, I talked to my parent, my father. I told him, Papa, yaar, maza nahi aa raha hai yahan pe. I'm not enjoying my work at all, and I want to change to teaching permanently. He told me one thing clearly: will you enjoy this? Do you feel that you have good career, long career in this? And do you feel that you can earn that much that you will be happy with that? All answers are yes. Then go ahead. मेरे को कोई problem नहीं, तू क्या काम कर रहा है, तू खुश रहे बस. That's it. Same thing I asked to my wife also, कि क्या करें? She told the same thing. If you are happy, doesn't matter how much we will earn, we will see. We are talented people, we can do it. Little bit weak in general aptitude. What should I do? In general aptitude, Lakshmi, you just solve the PYQs of aptitude. That's the only thing. Okay. Abdul, आपका डाउट लेते हैं लास्ट में. चलिए, let's begin the revision of short notes. If we will have time later on, we can continue our talk. So, in operating system, all the operating systems apart from the Apple's OS and Microsoft OS, all are the multi-user operating systems. So Unix, Linux, and all the versions of Unix, Linux are multi-user OS. Multitasking OS uses the RR algorithm. That is the time sharing also. We use the dual mode of operation like system mode and user mode just to provide the system protection. That you in user mode, user processes cannot execute such kind of instructions which require some kind of a privileged operation. So that's why any privileged operation needed, user process will have to have one system call, and through that system call, user process will ask operating system to do this task. That's why protected the system. दीपक, कल की सेशन देख लेना मेरी प्रोफाइल में जाके, स्पेशल क्लासेस में मिल जाएगा, डाउनलोड कर. A process is stored in 4 parts in main memory. Yes, data section, code section, heap, stack. Data section, fixed size, created when the file process is created, and it stores global variable and static variable. Code section, fixed size again, and it will have the instructions of the program. Heap and stack are variable sizes just because at the runtime they may increase or decrease. So if we need any dynamic memory allocation, happens in heap. In stack, local variable, function parameter, return addresses. In all, activation record are stored here in the stack. When the activation record created, whenever a new function call happens, when the function call is over, then activation record removed from the stack. So for every function call, there is an activation record created and then return. In kernel mode, process cannot be preempted. It is not true always. It's not true always. Anyway, if it is kernel mode, means operating system process is running. User process cannot preempt operating system process, but OS process can preempt OS process. Attributes of process maintained and controlled by OS through program control box or process control block, PCB. Process control block. This PCB contains a lot of information. Process ka ID, different register contents, then process status, process priority, memory limits, etc. Sub. Right? And through this PCB only operating system is controlling each and every process. If any process we say that currently process in ready queue, means its PCB is kept in ready queue under OS control. If we say a process has gone for waiting, means process ka status will be changed and that process ka PCB will be added into the waiting queue of that device. Next, process cannot access its own PCB. Yes, it's a control block which comes under OS. Process cannot access its own PCB. Next, the content of PCB of a process are collectively known as context. Inside the PCB, whatever content is there, that is called as context. So whenever context switch happens, these register values are, first of all, current running processes ka all the register values will be coming back to the PCB of that process, and other process which will run next, iska PCB content will go into the CPU register. That is how the context switch happens. So register content, why we need register content? Just because we want to resume the processes further. If we want to stop current process run, we want to resume it later, we will store its all the register values from CPU to its PCB. And for each register in PCB, you will be having one particular AR के लिए field, PC के लिए field, accumulator के लिए field, status register के लिए field. In PCB, each register field will be there. Good morning. Class started 18 minutes ago. Now you will say, I didn't get the notification, sir. है ना? रोज का यही बहाना होती है, हमेशा लेट आते हो. Okay, चल, let's go. Let's go. अरे, it's okay. You are the person who comes early always, but it's fine. रोस्ट होना लिखा है तुम्हारी लाइफ में, हो रहे हो तुम. A process in main memory, if it is in ready state or running state or blocked state. Process means the four content of the process. ये चार process के content, instructions, data, and everything will be in main memory. If process is in which state? If it is in running state, yes, process ka this content will be there in the main memory itself. Then if process is in ready state, then two. Process is in blocked state, then two. Only PCB and status and few things other change, but this content will be in main memory as it is. Of course, if process is in new state, the process has not loaded into main memory. Once the process terminated, means no, it is not in main memory. If process is suspended, then too it is just because swapped out from the main memory, it's not in main. So only these three states, if process is in, then these four part of process definitely will be there in the main memory. A process is deallocated from memory when terminated or swapped out. Deallocated means the memory allocation is removed. But sometimes it happens that a process has completed, terminated, but its memory has not been deallocated. That process is called as zombie process. Somebody asked just now. It happens, but that's like an error, because of some error or some specific problem, it happens, but that's not very usual one. Two transitions in the process state are the voluntary, means process can take by itself, running to terminate it, process can initiate and can do it, running to block, process can do it. शेड्यूलिंग एल्गोरिदम प्रोसेस को वेटिंग स्टेट से रेडी स्टेट में लाता है? नहीं. शेड्यूलिंग एल्गोरिदम प्रोसेस को रेडी स्टेट से कौन सी प्रोसेस रनिंग स्टेट में जाएगी वो सिलेक्ट कराता है. Then we have a long-term scheduler, which maintains a good mix of CPU bound and IO bound processes. Why? Just because the long-term scheduler will decide that which particular process will come into main memory or into the ready state next from the new state. Yes, Suchita, once the class is over, after half an hour, again, you will come to the same class link. You will be able to have the option of downloading the PDF from here. Okay. Next, we have here short-term scheduler only schedules the processes, means only decides that which process is going to run next. Scheduling algorithms, FCFS or first come first serve or FIFO, whatever algorithm you call it as. Then we have SRTF, SJF, priority based, RR. All these algorithms are part of short-term scheduler. So they are just deciding that P1 will go next or P3 will go next, etc. But context switch is done by the dispatcher. Dispatcher will bring the process from main memory to, or the context to CPU and vice versa. Sir, my app suddenly closed, might happen because of OS preempt something my app was using. No, नहीं ऐसा नहीं होता है. ऐप अगर सडनली क्लोज होती है तो ये ऐप की गड़बड़ है, ऐप में कुछ प्रॉब्लम है. How often zombie process will be cleaned by OS? In general, OS will not let the zombie process created, but still it will be closed frequently, maybe in 15 minutes or something, or maybe lesser than that. Yes, MTS, medium term scheduler, can increase, can decrease the degree of multi-programming. Long-term scheduler can only increase the degree of multi-programming. Short-term scheduler does not have any kind of impact on degree of multi-programming. Scheduling का goal क्या है? If we do the CPU scheduling or process scheduling on CPU, it will try to minimize the waiting time and turnaround time. It will try to maximize the CPU utilization. FCFS algorithm suffers from convo effect. SJF gives the minimum average waiting time for non-preemptive scheduling. Remember, non-preemptive scheduling algorithm are only used then minimum average waiting time and minimum average turnaround time we can get from the SJF only. Okay, but if all the algorithms are included, preemptive, non-preemptive, all, or only preemptive also, SRTF gives you the minimum average waiting time and minimum average turnaround time. So is it like, if we talk about SRTF, minimum or average waiting time in SRTF will always be lesser than average waiting time in any other algorithm? No, it can be equal also. It is possible that other algorithm also giving you equal waiting time as SRTF, but never will give you lesser than this. इससे कम किसी में नहीं मिलेगी. Sometimes processes are executing in the same way as SRTF is executing the processes in other algorithm also. So it might possible that SRTF and other algorithms are giving you average waiting time exactly same. But most of the time in general scenarios, practical scenarios, not in general scenarios, SRTF will give you minimum average waiting time. Sometimes a question may be asked that calculate minimum average waiting time to execute these processes. No algorithm is given. You will have to understand which algorithm they want to run. Non-preemptive, use SJF. Preemptive, use SRTF. Nothing is written, go for SRTF. LRTF is opposite of SRTF. Okay? Opposite of it. Of course, in the scheduling, they will schedule the longest process first. RR is used for interactiveness. If we want that multiple processes run together one by one by one by one by one, and a good interactiveness we want for all the processes, we want all the processes should give the responses quick, then RR is best. SJF, SRTF and priority based algorithms suffer from starvation just because in SJF and SRTF long processes will starve. Priority based algorithm, low priority based or low priority process will starve. SRTF behaves same as SJF till all process arrive together. अगर सारी processes एक साथ arrive हो रही है, doesn't matter if all are arriving at 0 or 1 or 2 or something, then definitely it happens. Do you teach advanced computer architecture? Nahi beta, it's not there in GATE syllabus, so I haven't taught it. Never I have taught it in the online media. No. So if all the processes are arriving together, then there will not be any preemption at all. You know preemption happens when? Preemption kab hota hai in SRTF? Preemption happens when the later arriving process is shorter than current running process. Then current running process will be preempted. But if there is no any process later arriving at all, then there will not be any kind of preemption. So if no preemption, then SRTF, SJF will behave exactly same to same. In priority based algorithm also, if all processes arrive same time, then there will not be any difference between preemptive and non-preemptive version. Both will work same to same. You will schedule the processes based on their priority, higher priority first, next. No preemption at all. Preemption only occurs when later arriving process is having shorter burst time in SRTF or higher priority in the priority based algorithm. In these two algorithms only I am talking about. In LRTF and RR, it can happen even if processes arrived at the same time also. सारी processes एक time पे भी आई हैं, तो भी RR and LRTF may impose some kind of what? Preemption. Depends what is the quantum, what is the burst time of processes, and in LRTF, what is the burst time of different processes. Based on it, we may have preemption. Preemptive and non-preemptive priority-based algorithm behave same if all processes arrive together, as I told. Doesn't matter if all processes are arriving at 0 or 1 or 2. If all are arriving at 2, 0 to 2, CPU will be idle. After that, we will run the processes one by one based on their priority. But all will run in the same manner in both of the algorithms, preemptive, non-preemptive, same to same. Okay, RR provides minimum average response time. Response time will be very quick in RR just because the processes are running. Processes are running in the what? Processes are running in the quantum basis. First, a process runs for short duration, then next. So all will get their chances in the quick succession. If burst time is greater than or lesser than or equal to the quantum, maximum of burst time of all processes is lesser than or equal to the quantum, or quantum is greater than burst time of all processes, then RR reduces or degenerates to FCF. Okay, I'll take your questions. Wait for some time. Here, what is given? 1 minus p to the power n. CPU utilization is equal to 1 minus p to the power n, where p is probability of IO operation time and n is the number of utilize the CPU. If p is the probability that a particular process goes for IO operation, etc., 1 minus p to the power n is the CPU utilization. What are the things which are shared among the threads? Code section, data section, OS resources, files and signals. What is the unique for each thread? Thread का ID, register set, different registers, program counter, etc. Stack program counter. Okay, can you please tell me what is the case of heap? Heap is shared or unique for each thread? Individual for each thread or shared between the threads? Heap shared होती है या नहीं होती है? It is shared. Yes. So we'll keep heap also here. It is shared between all the threads. Now, if we talk about user thread and kernel thread, user thread multi-threading is used in user process, multi-threading used in kernel process. Operating system itself is multi-threaded. Created without kernel intervention means in user thread, if multi-threading has been done, kernel doesn't know about it. Kernel को इसके बारे में पता नहीं होता है. Operating system doesn't know that user process has been multi-threaded at all. Kernel thread multi-threaded means kernel itself is multi-threaded. Kernel knows about it. Then we have, if one thread is blocked, operating system block entire process just because operating system doesn't know actually that we have one thread blocked or OS process is blocked. OS will not have information about the threads. So OS will understand, okay, process is blocked, process is blocked. Here, if individual thread is blocked, only individual thread is blocked just because kernel knows I do have multiple threads. Generic it is, and it can run on any of the operating system just because process has been multi-threaded. Kernel thread specific to OS just because operating system itself is multi-threaded. It is faster to create and manage. It is slower to create and manage. These points you please remember, direct question may come from these points. Waiting time is completion time minus Vikram, IO time भी remove करना पड़ेगा. Remove the IO time also. What is the meaning of user thread are transparent to kernel? What is the meaning of transparency? You tell me. What is the meaning of transparency? तो आप पढ़ते नहीं हो. What is the meaning of transparency in computation? See, अगर ऐसी कोई छोटी छोटी चीजें आती है ना, you guys are having Google. What is the meaning of transparency? Or you don't even write what is transparency meaning in computing. Just write these 3 words and you will understand what is the meaning. Read करके पढ़ो. Simple सा आंसर मिलेगा आपको और आपको याद भी रहेगा. See, transparency here meaning is visible. Are the kernel thread, user thread visible to kernel? No, not visible. Simple. These are the system calls. If you would like to have these. आपको भी गणतंत्र दिवस की बहुत बहुत हार्दिक शुभकामनाएं. जगमल, लोगों को गणतंत्र बोलना भी नहीं आता है आज. ऐसी हालत हो गई है जिंदगी. आता है आप लोगों को प्रोनाउंस करना है? आता है. मुझे कैसे पता चलेगा? सबको माइक पे लूं एक एक करके. Okay. I have learned this. हाँ जी, बिल्कुल विक्रम. सारे CPU टाइम, सारा IO टाइम आपको सब्ट्रैक्ट करना पड़ेगा कंप्लीशन टर्न अराउंड टाइम में से, तब जाके वेटिंग टाइम मिलेगा. चलिए. गणतंत्र. Okay, anyway, let's go for the next one. Semaphores. Semaphores are used for providing mutual exclusions, used for controlling the access to the resources. For mutual exclusions, when we use the semaphores, these are the binary semaphores used for the mutual exclusion. Controlling the access to the resources, we use the counting semaphores. Then solution using semaphores can lead to have deadlock or starvations. Using semaphore, if we are having, it may have busy waiting. If we don't want busy waiting, there is also possible solution for the same. Semaphore may lead to have priority inversion. Priority inversion is nothing but a high priority process is waiting and low priority process is getting the context switch, or critical section. It might possible that critical section is given to a low priority process and a high priority process is still waiting and not getting the critical section. That is priority inversion. Okay, next. Semaphore are machine independent, means it can run on any of the hardware. Signal S can run on binary semaphore successfully. Yes, signal S will run always successfully, but it will not increase the value of semaphore from 1 to 2 if binary semaphore is there. So if binary semaphore already having one value, binary semaphore pe signal S will run successfully, but it will not make it to 2. It will be 1 only, just because it's a binary semaphore. प्रायोरिटी इन्वर्जन इज स्पिन लॉक नहीं. प्रायोरिटी इन्वर्जन एक प्रॉब्लम है जिसमें कि प्रायोरिटी उल्टी हो जाती है कि हाई प्रायोरिटी प्रोसेस वेट करती रह जाए और लो प्रायोरिटी प्रोसेस को क्रिटिकल सेक्शन मिल जाए. अब ये इसमें स्पिन लॉक का कहां से बात आई? चल आगे बढ़ते हैं. What is given further this? Some of the ways to avoid deadlocks are following. If we have, it's in dining philosopher problem. Dining philosopher problem is this. But high priority process cannot enter into critical section then. It will enter afterwards na, once the low priority process will leave the critical section, तो high priority वाले को मिलेगा बाद में. If we will have one less philosopher, then we can avoid deadlock. If philosopher will start picking up the chopsticks only when both are available, otherwise not, then two. Here one philosopher should pick the left chopstick first, remaining all are taking right, means we are not allowing the circular weight. We can avoid the deadlock. Deadlock recovery can be done through these three things. Make sure deadlock never occurs. It is having two solutions: deadlock avoidance and prevention. Deadlock occurs, detect and recover. Pretend that there is no any deadlock. It is called as ostrich solution. If we want to have deadlock prevention says that among four necessary conditions. What are the four necessary conditions? Mutual exclusion of the resources. Second, hold and wait. Third, no preemption of resources. And fourth, circular weight. Among these four, if any one also not holding, then deadlock can be prevented. So deadlock prevention will try to prevent one of the necessary conditions of deadlock. Okay. Then deadlock prevention is stricter than avoidance. Remember this. Suchita, you can access the lectures of Saurabh Thakur sir on a channel FT Express. Okay. Next, deadlock detection when all the resources have single instances. Wait for graph. If multiple instances of each resource we have, then we will have the specific method, which is Banker's algorithm. Right? Cycle in wait for graph means deadlock. If we have single instance of each resource. If resources are having multiple instances, cycle means deadlock. It's not guaranteed. There may be, there may not be. Sir, prevention stricter than avoidance. Why? नहीं जानना हमें रीजन. मैं बोलूं मेरे को भी नहीं मालूम, बस ठीक है. चल, अरे नहीं जानना हमें रीजन है, बस होता है. To ensure the deadlock, minimum number of resources needed are equal to For each process, whatever the maximum need, minus 1, summation for all the processes plus 1. If this plus 1 will not be there, then deadlock may occur for maximum these resources also. दीपक जी करते हैं बात, लॉक पे आते हैं. Okay, we will have different types of lock. One is spin lock. Spin lock is nothing but busy waiting. A process can be in busy waiting. Single process can stuck in spin lock, while loop, condition, semicolon. Process can continue running this particular condition on CPU, and then process will stuck into that condition until the condition becomes false. So that is a spin lock, busy waiting. Then we have deadlock. In deadlock, what happens? Processes are blocked. Actually, processes are blocked because of each other, and they are in the waiting state. Deadlock. Then we have, similar to deadlock, the first cousin, the sibling of deadlock, called as live lock. What is the difference? The difference is it is exactly kind of a deadlock. Rather than processes are blocked in the waiting state, processes are running in while loop. Two processes are running their while loop, and both are stuck. They are not able to go forward. So they will go for running, but the process cannot go further. Then after context switch, other process will run on CPU, and this process also stuck. So the no progress is there, yes, but processes are running on CPU rather than blocked. That is also live lock. Sometimes in some of the solutions, they refer it as a deadlock also. Live lock, deadlock, कभी कभी same to same लेते हैं. Like two question is given, two process code is given, and they are asking that these two processes running, deadlock avoided or not, or prevented or not. So actually it will be live lock. Processes are having their while loop, but it is sometimes referred as live lock also or deadlock also. Difference I have explained. Sure. Memory management. Memory management, each process has its own page table. We know that if 15 processes are there, 15 page tables will be there in the system. Operating system will manage 15 page tables for 15 processes. Whenever process is created, if we have the paging system, we will have the page table also. Page table is stored in main memory in the frames itself. If process page table can't be stored on single page, then multi-level paging we will use. If paging is used, then page table, the address translation is required even if process is of one page itself. अगर process में एक ही page है तो भी page table required होगी, just because system CPU will always generate the logical address. So translation is always needed. Number of entries into page table is equal to number of pages. As many as pages, as many as entries into page table. What is the page table ka size? Number of pages into one entry ka size. In one entry, what we have? Frame number plus extra bits. Now, if extra bits, what kind of bits we can have? Valid, invalid bit, just to say that the specific page is there in the main memory or not, which can help us understanding it's a hit in the main memory or it's a page fault. If for one page table entry is invalid, means the page is not available in main memory, means it's a page fault, right? Apart from that, we can have dirty bit in the just to say that we will have to replace a particular page from main memory. That page will be written back to the disk or not. If it is dirty, then only written back, otherwise not. We can save a lot of time. It's not cache, it is kind of a cache only, but write back of page will be required only for the dirty pages. You may have some extra replacement bits, etc also. Fine, but minimum frame number bits should be there in one page table entry. Logical address we divide into two parts: page number and offset. Physical address, frame number and offset. If effective memory access time, I'll have to calculate twice of main memory access by default. Why? One for page table, one for content. If we have page table very small and stored in the registers, entire page table, then only one time main memory access time, just because page table access time will be ignored. If we have used TLB, effective memory access time will be equal to this as a small formula. In general, it is like this way, that when there is a hit in TLB, one TLB ka access time plus one main memory ka access time. Plus when there is a miss in TLB, one TLB access time and twice of main memory access time. This is the formula. But look at this, 90% hit, 10% miss, as many as percentage of hit, inverse of that miss, दोनों बार एक बार का TLB access time, both time one TLB access time here and here also, 90%, 10%, both time TLB access and one main memory access anyway needed. So I have written it anyway. And when there is a miss, extra main memory access time needed. Why we have same access time for page table and main memory? Because page table is in main memory and content is also in main memory, तो बराबर टाइम लेंगे. ये देखो, पेज टेबल को रखने के लिए अलग से थोड़ी मेमोरी है. Further, direct mapped TLB, if we have, then logical address, complete logical address, we divide into two parts, P and D, and now P we will divide into two parts, TLB का entry number and time. Set associative mapped TLB, if we have, then we will divide P page numbering into two parts, tag and set number. If fully associative we will be having, then P itself is tag, D is D. Complete entire thing will become, page number itself will become the tag. Optimal page size, if you want to calculate, under root of twice of page process size into page table entry size. If you want to calculate what should be the optimal page size based on the page table entry size and process size, this will be the answer. Next, size of segments can vary, of course. So along with base address, we keep the limit information also so that we can provide the protection. Paging solves external fragmentation. This is true, yes. Paging does not have external fragmentation just because we have equal size pages. Cache कल revise हुआ था बेटा. Limit defines maximum number of words or bytes within a segment. Paging suffers from internal fragmentation only. Why? Just because there will not be any case that we do have space available and we cannot keep a page. If we have one page to be stored, that page ka one frame we will have always there. External fragmentation है ही नहीं paging में, कभी भी नहीं. Then segmentation may suffer from external fragmentation but not from internal one. Valid page in the page table helps to ensure the page hit or page fault. Page valid bit, as already we have discussed. When there is a page fault, effective memory access time will be 1 minus P into OHO, twice of TMM आना चाहिए. Twice of TMM here. When there is no any page fault, 2 times main memory access. Why? 1 for page table, 1 for content. When there is a page fault, then page fault service time is required. If TLB is used, when there is a hit in TLB, TLB access time and main memory access time needed. When there is a miss in TLB, one TLB access time needed to just check TLB miss. Main memory access time needed just to check if it's hit or miss in page table. Then this. If no page fault, one more TMM. If page fault, service time needed. So, but page fault can occur only when there is miss in TLB. Page fault will never occur when there is a hit in TLB. Hit in TLB means page is there in main memory. That's why its entry is there in the TLB. Thank you so much, Suchita. Thank you. यहाँ डर्टी ही हो सकती है ना? हाँ बिल्कुल. यहाँ पे डर्टी का अगर सीन आएगा तो ये और एक्सपैंड हो जाएगा. When page fault, this may be expanded further. In when page fault, we will be having page transfer time separate for dirty and non-dirty pages. Fraction or extend हो जाएगा. Page fault service time includes TMM after bringing the page to main memory. Yes. Abhishek, bring the page to the main memory, but to access that content we will have another access. तो वो access page table में hit होगा. उसके लिए अलग से एक्सेस जनरेट करना पड़ता है. So we don't have to add that here. The page fault service time is just to bring a page from hard disk to main memory, replacement, etc., updating the page table, etc. What is the default memory access method here? It's all hierarchical in this operating system scenario. Page fault is an internal interrupt to OS, yes, and operating system services it. How? Operating system brings the faulted page from hard disk to main memory, and then the instruction which faulted or which had the page fault, that instruction again restarts. It's not resuming, it restarts, and it will have again the same memory access once again, and that particular access will have a hit over here. तो ललित, ये जो THD आपने लिखा है वो क्या है? टाइम ऑफ हार्ड डिस्क. हमें ट्रांसफर टाइम चाहिए, सिर्फ हार्ड डिस्क नहीं. पेज सर्विस इज डन इन द कर्नल मोड. हाँ जी, कर्नल मोड. पेज फॉल्ट में फ्रॉम वेयर टू वेयर वी आर ब्रिंगिंग द कंटेंट? इन पेज फॉल्ट फ्रॉम वेयर टू वेयर वी आर ब्रिंगिंग द कंटेंट? Hard disk to main memory, hard disk to secondary memory to main memory. Secondary memory is IO device. Yes, it's peripheral device. So peripheral device to main memory, if we transfer the data, we may need here either interrupt service or we may need here DMA service for the page fault service. Okay, just to bring the content from peripheral IO device disk to main memory. कहाँ की बात कहाँ जोड़ देते हो सर? Once you will get married, you will understand. Wives are like that way. Experience. Chaliye, let's come back here. So page fault service, the current memory access instruction restarts. Whichever memory access instruction which has faulted the page, that will restart again. FIFO page replacement policy suffers from Baladi's anomaly. What is that Baladi's anomaly? If there is a problem. What is the problem? If there is what page fault, number of page fault are there. If we increase the frames, the page fault may increase for certain page reference sequence. That is Baladi's anomaly. Increasing the page frames may increase the page fault for a specific sequence. That is Baladi's anomaly. Optimal page replacement policy provides minimum page faults. So if in the question asked that these are the page reference sequences, give the minimum page faults, you will use the optimal policy. Stack property doesn't follow. Which one? यहाँ पे यहाँ नहीं हो सकता. Current instruction complete ही नहीं हो रहा है. Current instruction is not even completing, and that current instruction itself is having fault. So how can we have that stack property, etc.? Current instruction cannot complete without accessing the memory. Memory is not having the content which we need. So current instruction will restart to access the same content which faulted previously. So apart from such kind of policies which are using the stack based algorithms, all will have the Baladi's anomaly. So while replacement, only dirty pages return back to the secondary disk. Yes, thrashing is like high level paging activity. What does it mean? If page faults are so many, just because we are not able to keep so many pages in the main memory for a process, so many page faults will occur, and because of that CPU utilization will reduce. CPU will not execute a lot of processes, rather than will continue doing the page fault service. So in that sense, the long-term scheduler will increase the processes more in main memory, in the assumption that let's increase the processes so that I can increase the degree of multi-programming, and hence we can increase the CPU utilization. But it doesn't happen. Even though number of processes will increase, thrashing will increase, and CPU utilization will become zero. Problems, then solution is this of thrashing: working set model and page frequency model. We don't have to go through this once again in detail. छोड़ सकते हैं इसे. This table, from this table, there was a question last year in GATE exam. One numerical. How much or how many block accesses are needed, etc. So we have file allocation methods, contiguous, linked, and index. In contiguous, file access is sequential and random both, but we have external and internal both fragmentation. In linked, we can have only sequential access. So disadvantage, of course, but good part is only internal fragmentation we can have within the blocks. Indexed one, sequential and random both access plus only internal fragmentation in index. Internal fragmentation will occur in all the type of storage for sure. Random means directly, yes. किसी भी block को आप directly access कर सकते हो किसी file के. In the disk scheduling, SSTF will provide the minimum cylinder moves. I guess we have that much only for the day. डिजिटल नोट्स क्लास के नोट्स में कितना डिफरेंस है? बहुत डिफरेंस है बेटा. इन्वर्टेड पेजिंग दीपक कभी क्वेश्चन आया नहीं उससे ज्यादा. If we have P1 number of bits, P2 number of bits, P3 number of bits in the multi-level paging, number of pages to store all page table pages across all the levels is equal to 1 plus 2 power P1 plus 2 power P1 into 2 power P2. ठीक से लिखें इसे. 1 plus 2 power P1 plus 2 power P1 into power P2. These many pages needed. If you multiply this by page size, you will be having the total page table page size, that how much space is needed. Total memory required to store an entire. आज और भी कोई क्लास है? हाँ जी है. अभी एक 12:30 पे क्लास है जिसमें हम बात करेंगे डेटा स्ट्रक्चर के शॉर्ट नोट्स के बारे में. सीक टाइम कैलकुलेशन, लीनियर वेलोसिटी, RPM फ्रॉम ट्रैक इनिशियल टू जे टाइप क्वेश्चन 2007. चंदन जरूरत नहीं है उसकी क्योंकि अब यूज नहीं होता है. वो टाइप का डिस्क अब यूज ही नहीं होता है. 15 साल हो गए उसके, अभी यूज में नहीं आते हैं. इंटर प्रोसेस कम्युनिकेशन की प्रॉब्लम. आजकल तो डायरेक्ट स्टोरेज आ गई है. हाँ जी, डायरेक्ट स्टोरेज आ गई है. यार आप लोगों के क्वेश्चन अभी ले नहीं पाएंगे जस्ट बिकॉज ओनली 2 minutes रिमेनिंग फॉर दिस क्लास एंड आफ्टर 15 minutes वी हैव अनदर क्लास. So for doubts, I'll take another class later on. अब्दुल, आपका जो क्वेश्चन है पहले ये बताओ ब्लॉक का साइज क्या दे रखा है? ब्लॉक का साइज क्या दे रखा है बताओ. ब्लॉक का साइज है 2 power m वर्ड्स और बाइट वर्ड का साइज क्या दे रखा है? 2 power w बाइट्स. तो ब्लॉक का साइज होगा 2 power m इंटू 2 power w बाइट्स. मतलब कि 2 power m प्लस, और अगर बाइट ऑफसेट निकालोगे तो m प्लस w आ जाएगा आंसर. Even if you use operator, we can't save load store stars, right? उमेश, हाँ जी, इन जनरल तो नहीं कर सकते, पर प्रोसेसर टू प्रोसेसर डिपेंड करता है. 2 power m प्लस w आ जाएगा बाइट में ब्लॉक का साइज. तो m प्लस w बिट्स आपके पास आंसर आएगा. जो लोग अभी एड्रेस साइज डिक्रीज नहीं, क्यों एड्रेस साइज डिक्रीज क्यों होगी? मेन मेमोरी तो बाइट एड्रेसेबल ही है ना. मेन मेमोरी बाइट एड्रेसेबल ही है, वो चेंज नहीं होगा। ब्लॉक को बाइट में कन्वर्ट करा दो, काम खत्म, कोई चेंजेस नहीं आएंगे। IEEE में ओवरफ्लो प्रॉब्लम इज कन्वेंशनल इज NaN। उदयन ऐसा है, NaN जो है वो हमारे यहाँ पे ऐसा है कि हम स्टोर तो कर पा रहे हैं उनकी बिट्स को, बट वो हमारी स्पेशल कैटेगरी में आता है, इसलिए और भी ओवरफ्लो भी आ सकता है, NaN के ऊपर भी ओवरफ्लो आ सकता है। ललित बाद में देखेंगे। चलिए, I'll have to stop the session, but before that, remember this: for Republic Day offer is running on 30%. You can save only up to 28th of January. Take the subscription using the code and enjoy your learning. चलिए, थैंक यू सो मच। अभी जितने भी लोगों के जितने भी हेड हैं प्रोफाइल में जाके, मी सेक्शन में जाके अपनी ऐप पे ये इसको डेडिकेट करो अभी के अभी, सारे के सारे। जी हाँ, ये जरूरी है। सारे डेडिकेशन हेड जो आपकी प्रोफाइल में है वो आपको देना है अपने फेवरेट एजुकेटर्स को विद द वर्ड्स यू वांट टू राइट अबाउट देम। करो, अभी करो। चलिए, मिलते हैं आपसे 15 मिनट्स में अगेन। थैंक यू सो मच।